All right, wanted to make a quick video, give you guys kind of an overview of what I do with my 4,000 gallon koi pond, how I keep an eye on the water parameters, how I test, how I interpret the results personally, and what kind of actions I take based on the readings I get. So as you saw just a couple seconds ago, we walked out, got a cup of water. I find it just a lot easier to just get a sample of water, do the testing here in the kitchen. This is my little junk box here where I keep all of my water testing, small amounts of medication, other little miscellaneous equipment. So this is just an old makeup box that my wife stopped using, so it turned out to be perfect for all of my koi pond and aquarium junk here. So in here I have a couple of different test kits, different brands and whatnot. But my kind of go-to everyday or routine regular testing is the API liquid test kit. So I like the freshwater master kit. So they come in a little plastic box with a holding tray. You get basically most of the water parameters you need to be testing, and you get a couple of these little glass vials here to do the testing. I also have other test kits as well. Let's see. So I have in here. Got a couple of test strips, so I have something for like the potassium permanganate whenever I do that dosing. I have these the nitrite, the test strips, and nitrate as well. I like to just confirm what I'm getting on the API liquid test it with these test strips, just to make sure that both results are kind of in line, and one is not giving me false readings. For nitrite as well, I also have the Salifert. This is a powder test kit. I like to use this one again when I was cycling the pond, just to confirm the nitrite readings that I was getting from the API test kit. So it never really hurts to have more than one, more than one test. Different methods as well, making sure you're getting accurate readings all the time. So what I'm going to be testing today is just your standard array of water parameters that you should be checking. Any sort of freshwater setup for aquariums, koi ponds. So obviously the most basic is going to be pH. So we have the standard range and the high range pH kit. Testing ammonia. Nitrite. Nitrate. And KH and GH, so carbonate and general hardness. I'm also going to be testing the salinity of the water. I use this Koi Medic digital salinity meter. These things I really like this thing. Comes in very handy, especially if you're using salt as a medication. You really want to know what your salt levels are, and this is also a really easy way to figure out the exact gallons that are in your pond. So using your starting baseline of your salinity, add a set amount of salt, and then you measure the salinity afterwards. And there's a couple of calculators online that will pretty much spit out the exact gallonage of your pond using the mathematical relationship between salinity and pond water volume. So on the salinity, it's been a couple of weeks since I added salt. Like I said, I really use it as a general tonic. Some people like to keep salinity levels at about 0.10% at all times. I really don't have reason to add it, but I do test the salinity of the water just to see what that is. So again, we have our pond's water sample here. Turn this thing on, and then you just go ahead and dump it right into your sample. Let's see if we can show what that looks like here. And it'll take a couple of seconds for it to stabilize. So you can see we're at 0.01%, which is almost basically nothing. So like I said, I added a 40-pound bag several months back, and throughout the water changes that I'm doing with the pond, that kind of tends to go away on its own over time. So basically no salt level in the pond for the time being. Start off, we're going to fill our test vials with samples of pond water. I like to use these plastic syringes to fill up the individual glass vials. I find it makes it a lot easier, get the right amount of water in there. Fill this up, and you want to get it to right about the line there. You don't want to over or underfill it, because obviously it's going to impact your test results there. So you want the bottom of the curve of the water to be right at the top of that line there. So you want the water to be right around the curve of the water to be right at the top of that line. So you can see that's right about where we want to be for these things. So I'll go ahead and fill up the rest and we'll get started. All right, we'll start with the basic test, which is pH. So if you don't really know where your water is or where your pH generally is, I would say use both the pH and the high range. I would not recommend getting those all-in-one pH test kits, the ones that test from a very low range all the way up into the very 8 to 9 pH range. Those tend to be not as accurate, and there's a lot. It's very hard to tell. If you look at the color charts on these liquid test kits, it's very hard to tell where you actually land. So I recommend the API freshwater master kit that that has both. I buffer my water so I know my pH is always going to be in the high range. So for that reason, I'm not even going to bother with the low range pH. We're going to go straight into the high range. So again, these things, always shake them up very well. Make sure that you're using a test kit that's still valid, not expired. These are nice kits, but they're not perfect. They're not lab grade equipment. They tend to go bad, and they'll give you false readings a lot if you're using an old bottle. So it's hard to tell there, but I think these things expire. Let me see if I can find another one here. Looks like most of these are good till 2022. It's a little bit worn off there, so should be good. So again, give these guys a good shake. And so the booklet has all of the instructions, as well as the bottle. There's a couple of nuances with some of the other test kits that I'll mention here, but for the most part, these are pretty straightforward. Just add the number of drops, and that's about it. Okay, high range pH calls for 5 drops. We'll get that in there. 1, 2, 3, 4, 5. Cap it, give it a good shake. And so the normal instructions are you have to wait for 5 minutes. So I'll go ahead and fill all these up, and we'll let them sit, and we'll come back and read all the results. The Ammonia Test Kit is 2 separate bottles. Each one is 8 drops. So go ahead and fill those up. Again, shake the bottles. Nitrite is 5 drops. Okay, nitrates. This one I think deserves its own section because this is one that almost everybody gets wrong all of the time because they're not following the instructions and they're just seeing what it says here. Add 10 drops of this one, 10 drops of that one, shake it up and call it good, and you interpret the readings. If you look at the chart here, the color chart, all right, so you can see the nitrate one over here on the right. If you're not doing this test right, you're going to get the 0 ppm reading. It's going to be very yellow, almost a very light goldish color. My theory is that 0 nitrates are almost virtually impossible in a closed circuit, closed system, especially when you have a heavy fish load. You might be able to get it low, but it's never going to be 0. I know a lot of people when they test these things, when they're posting their results online, they're always saying 0 nitrate, 0 nitrate, and I find that very hard to believe. I think it's either they're not following the instructions correctly, or the test kits are bad. So if you read the booklet, it's a little bit more involved with these. So first of all, you want to shake these very well. Number one, this one you want to shake it vigorously, the second bottle, for 30 seconds before you add it to the vial. Then after you add the drops from both bottles, you want to shake the bottle vigorously for another minute, and then let it sit for 5 minutes before you read the results. So I think these are the steps that people miss, and it causes them to get false readings on their nitrate test kit. Because we're going to be doing a lot of shaking for over a minute on just the tube itself, I like to use a separate glass vial, and I'll show you that right now here. So these things, they do a horrible job of sealing the water. So if you're shaking this thing for a minute, after a minute, you're going to end up losing most of the liquid in here, and it could affect your readings. So for that reason, I like to, again, going back to my plastic syringe, I like to get this right around the 5 milliliter line, and then I use a separate glass vial which I have from another test. So these little glass vials here, it's a screw-on lid, and you can see it has a little rubber seal in there. So these are sealed very tight, virtually liquid tight. So you can shake it and you're not going to lose any drop of liquid whatsoever. So we'll go ahead and try to fill that up now. Take some of this excess water out. Now I'm going to spill a little bit of water here, but that's all right. So right around there should be exactly 5 milliliters, which is what the API test vial calls for. All right. So I take that 5 milliliters of water and I put it in this other test vial, not the API one. Make sure you get it all out. Okay. Bottle number 1 for nitrate. Shake that up real good. Add 10 drops. You got to be careful because sometimes these tubes require a lot of pressure to get the liquid out, and sometimes they'll just start flying out on you. Okay, 10. Second bottle. So remember, you want to shake this one vigorously for 30 seconds. So we'll come back after that time. Alright, we're shaking this one for 30 seconds. Go ahead and add 10 drops to the vial. So now we have both solutions of nitrate in here. Put this cap on tightly, and then you're going to want to shake this thing for a minute very vigorously. So. Alright, we've shaken this thing for a full minute, and as you can see, almost immediately the color is already starting to change a little bit. It's already got an orange tint, and we have not even waited the full 5 minutes that the instructions say for you to read the test results there. So what I like to do is I like to pour it out of here and pour it back into the API test vial, just so it makes it easier to compare with all the others next to the color chart. So we go ahead and do that now. And as you can see, we're above that 5 milliliter line because we've added 20 drops of liquid. Normally, if you were to do the shaking in just this tube, you'd probably be down here based on how much liquid you would have lost. So we'll let that sit and we'll come back and read the results. Okay, the first 3 tests that we did have had about 5 minutes to sit, so we can go ahead and start looking at those results now. So remember, the first one that we did was pH. We did the high range pH, and as I mentioned, I buffer my water with baking soda or sodium bicarbonate. And if you're adding the right amounts, which is about 1 pound per 1,000 gallons of water, your pH is normally going to buffer to be at about that 8.2 to 8.4 range. So sodium bicarbonate or baking soda has a pH of 8.3. So if your water is constantly buffered with the right amount, you should be very steady pH of 8.3 with a little bit of fluctuation based on nighttime, morning, and full noon at the hottest times of the day. So my pH, based on the fluctuations that I've the patterns I've noticed over time, I dip about around 8.1 to 8 during the coldest times of the day, so early morning, late at night. And in the peak, hottest times of the day, it'll climb up to about 8.3, maybe sometimes a little bit higher. So right now it's about 10 a.m. here, and as you can see, we can get a good result here. So my water is probably out in that 8.3, 8.4 range. See if I can get the right angle here to compare the color. These are a little tricky depending on how the light hits them. So it's somewhere in between there. So that's, for me, that's pretty much where it should be. That's acceptable. So like I said, I add baking soda every couple of weeks. So based on, if I test this in midday or mid afternoon, where I would expect my water to be in the low eights, 8.3 range, and if I see it's actually lower than that, so somewhere around here 7.8, 7.9, 8, then I know I need to add a little bit more baking soda because the buffering capacity of my water has gotten consumed. So again, pH is where I would expect it to be. No issues with that one. The next one that we did was the ammonia. So again, one thing to keep in mind is this thing is measuring total ammonia, which is ammonia NH3 plus ammonium NH4. So if I look at this thing, I mean, to me that's yellow. That's about as yellow as it can be, or it should be. So again, these things are very tricky depending on how you compare it to where the light is hitting it and how you're lining it up to the chart. So I interpret that as 0 or almost 0 ammonia, which is where obviously where you want it to be. So that's good. So before we move on to the other test kits, I wanted to talk a little bit more about this ammonia test kit. So as I mentioned, this is measuring TAN, or total ammonia nitrogen. These things, so it can give you a little bit of misleading results because it's not necessarily testing only the NH3 component, which is what is considered to be toxic ammonia. It's also testing NH4, which is your non-toxic or much less toxic ammonium. So a lot of people, if they start to see a little bit of green, they'll start to freak out and think that they're gonna start losing some fish. But you got to be careful with that because there's a relationship between temperature, pH, and your ammonia reading that you need to be aware of. So I brought out my log top here to show just a couple of reference charts that I find online. These are really helpful. So as you'll see here, the relationship between pH, ammonia toxicity, and temperature. So if you look up here, this is a chart for a 0.25 ppm reading of total ammonia, or this lime green color here on the API test kit. So as you can see here, even though it's giving you a reading of 0.25, the actual NH3 relationship, or the actual NH3 component of that reading, is going to be here. So you're in the 0.00, basically almost no ammonia, no toxic ammonia at all ranges of pH and temperature. So you see the pH scale goes from 7 to 8, and your temperature is from 68 Fahrenheit all the way up to 86. So as long as your pH is between 7 and 8, and your temperature is from 68 to 86, you're in the safe or the green zone with a reading of 0.25 on your API test kit. So the general school of thought is that your NH3 or your toxic ammonia should be 0.05 or less. So as you can see here, for that reason, everything is still in the safe zone. If we go down a little bit here to the 0.5 reading, which you start to get more in the more lime green on the chart, you can see that again, you're almost in the safe zone for basically all of these readings up until you get with a pH of 8 and your temperature starts to get above 79 degrees Fahrenheit. So from there you start to go in the warning zone. So the warning zone here would be anything more than 0.025 is what they consider, as what you should start to be paying attention. We go down to the 1 part per million, which you're already down here, so it's very green color on the API test kit. So with the reading of 1 part per million on your API test kit, you can see that you're pretty much safe as long as your pH is between 7 and about 7.8, and your temperature would be in the 60s here. Obviously, if your temperature is 86, you're safe as long as your pH is 7.4 or less. Once you start to get higher pH, higher temperatures, you can see over here, you're already near in that 0.482 range. Down here with a pH of 8 and a temperature of 79 degrees or higher, you're already in the red. You're already over that 0.05 parts per million of NH3 toxic ammonia, where it's considered to be detrimental for fish health. So we'll go down to the very last chart here, which is 4 parts per million. So again, if you reference this back to the API chart, you see this is a very dark forest green color. So even then, even if you get a very dark reading on your API test kit of 4 parts per million, as long as your pH is 7 and your temperature is below 79, you can actually see there's a potential to be in the safe zone of ammonia. So at here, you're at a reading of 0.024, which again, it's starting to get into that elevated level, but still well within the safe range, what's considered for safer fish. You can essentially go up to a pH of 7.4 as long as your temperature is in the low 70s. So there, again, you're 0.0456. Anything beyond 75 degrees or anything higher than a pH of 7.4, you're going to be in the full-on reds here. So again, this is a very dangerous area to be in. If you do get a reading like this of 4 parts per million in your API test kit, you want to make sure you start treating for it right away. All right, the third test that we did was the nitrite. So again, going back to our chart here, you can see the ranges for nitrate. It goes from 0 all the way up to 5 parts per million. Zoom in on that a little bit here. And here's our test kit after sitting for about 5 minutes. So if I can get the right angle there. So to me, that's basically 0 parts per million or somewhere in between. It's definitely not at the 0.25, which is good. This, on an established pond, something that's been fully cycled, running for several months, or a very mature system, you should not be showing any nitrites essentially ever. If you do, that's indicating your essentially your biological filtration is not keeping up with your fish load and your feeding load. So in my experience, when you're cycling a new system, ammonia is the one that takes a couple of weeks to build up. And once it builds up once your filter starts to get established, it'll start to go down in about 4 to 6 weeks. Nitrite, however, is the one that I've always struggled with. So this one here is the one that always takes, for me, a very long time for it to come down. From my experience, it can be anywhere from 2 to 3 months. I'll always have some sort of lingering residual nitrite reading. And so again, my pond was up and running April of last year. I was showing nitrite, well into the summer. And luckily now it's well established. So 0 parts per million of nitrite is where you want to be at all times on an established koi pond. So that's good there. All right, so our other test, which is a more complicated one, is nitrate. So this thing, again, has been sitting for about 5 minutes here. So this one, again, it's very hard to read once you get into this range down here. These colors kind of start to blend together. Very hard to discern from looking at this test file here. Obviously, the lower the better. That's where you want to be for fish ponds. Again, 0 parts per million, I find that very highly unlikely unless you've completely stopped feeding over the winter. That's where I would see readings about, in the 5 parts per million range. But now that I started feeding, temperature's starting to warm up, I would not expect to see anything low unless you're doing massive water changes or have some other form of nitrate removal, which is very uncommon. So if I look at this thing, try to get this lined up correctly. So to me, this looks like it's going to be in the... Try a different side over here. So I think that's somewhere 20 to 40, I think. Again, at this level, the colors start to kind of blend together. So it doesn't really look like it's full on red as in 40 parts per million. Definitely not the 80. It has a bit more orange to it. So I don't know. I'm going with about 30, 35 or so is kind of my interpretation for that. And so this is pretty much where my pond has been, even last year in the summer as well. So I do about 10% weekly water changes. So for me, my rule of thumb is somewhere 40 or less. That's kind of what I consider to be adequate. Obviously, it's not ideal, right? But again, you'd want it as low as possible. But on a heavily stocked fish pond, that's very difficult to do. So as long as you're not down here in the 80 to 100, the blood red area, I think, that's where you want to start looking at some other measures. So for me personally, 40 or above, 40 or less is where I look to be. All right, moving on to the next test is the KH, or carbon hardness, or also your alkalinity. So this is a very important test kit. This is the one that's going to help you prevent your pH crashes and keep your pH stable and rock solid throughout the day, throughout various temperature swings. If you have a lot of algae in your pond, that's also going to impact your pH as through the carbon dioxide release and consumption process as well. So the way these are measured are in drops. So you add drops of liquid one at a time to the vial until the fluid on this one changes from blue to yellow. So 1 drop or 1 degree is equivalent to about 17.9 parts per million. So for me personally, where I like to keep my pond is around 6 drops or higher. So that's about 120 parts per million. So the general rule of thumb for a koi pond is 100 parts per million or 6 drops or higher for your koi pond in order to maintain that, that adequate buffering capacity. So if I do this, typically my tap water tests about 5 drops. So that's a little bit under 100. So I'll add a little bit of baking soda to bump that back up to the pond. So we'll see what my water is right now. I imagine it's going to be somewhere in the 5 to 6 drop range, which it typically is. The last time I added baking soda was probably about 2 weeks ago. Once I do add that baking soda, it'll probably be in the 7 to 8 drops. So we'll see how that's come down over the last couple of weeks here. So I'm going to go ahead and just fast forward and add 3 drops because I know it's going to be above that range. 1, 2, 3. So we'll shake that up here. And I don't even bother with the test kit. I just put my finger in it since I tend to do a better job sealing. So 3 there, that doesn't change. Drop number 4. No change. 5. And there it is. So at the 5th drop, it changed. So I know that based on the 17.9 parts per million per drop, I'm under 100 parts per million of alkalinity or carbonate hardness in my pond. So that's a little bit lower than what I want to be, so I'll add some baking soda to that. So what I use is, I have just this big container here that I keep handy with all of my baking soda. So this is just, standard Arm & Hammer. I just keep it in this tub here. Quick way to measure, I just had some guidelines on here. So I add 1 pound per 1,000 gallons of water. So my pond is 4,000 gallons, so I would add 4 pounds of this and it'll bump up my carbonate hardness. It'll probably get into the 7 or 8 drops range, and that should hold me for a couple of weeks. And so again, your KH or your carbonate hardness, it's a very important test. So a lot of people, they have very water with very low buffering capacity. So at the first drop, this goes from blue to yellow immediately. So essentially no buffering capacity in the water. Those are very dangerous environments because what you can suffer is a wild pH crash. It can swing several points overnight. And that you can experience a lot of fish loss. It can be pretty much catastrophic for your pond. So typical, from day to night, you should see anywhere from 0.2 to 0.4 point fluctuation in your pH. So, like as I mentioned earlier, mine will typically go from 8.1 up to about 8.3, 8.4 at the warmest time of the day. And that's kind of around the normal range that you want to be. So right now it's still safe. So, I still have some buffering capacity at 5 drops. I like it to keep it a little bit higher just to keep the pH even more solid with less fluctuation. And again, to raise the pH, or sorry, not the pH, but the alkalinity or the carbonate hardness of the pond, and help with that buffering capacity. This is what I add: just pure Arm & Hammer baking soda. I get these bags on Amazon. Costco also has pretty good deals on their 13 pound packs. Some grocery stores also sell it in bulk by the pound. They got these those bins and containers. I like these. Just convenient. Get them on Amazon, shipped to your door, and these are just a couple of bucks a piece. So it's a very economical way to maintain your pH and buffer your water. So the last test we're going to do today is your GH, or general hardness. So this is measuring, the actual softness or hardness of your water. What's measuring, the calcium and magnesium. Essentially when you see all of that hard water buildup in your faucets and your plumbing and things like that, you're going to be very high in this test here, your GH. So my tap water, it's pretty soft. I would say relatively soft. So I measure about 4 drops, 4 drops of degrees of hardness. Convert that to parts per million, 17.9, it's about 80. So 80 parts per million of general hardness, which again, it's typically on the softer end of the scale. So not too hard, not too soft. So I would expect the koi pond is probably going to be around 4 drops as well. All right, so let's go ahead and get this one tested. The way this one works is you count the number of drops it takes to turn the liquid from a yellowish orange color to green. This is probably my least favorite one because it's very hard to tell when that color changes. It tends to sort of stay in that in-between range, and it's not too easy to discern the color. So my tap water, again, like I said, is typically 4 drops. I expect the pond to be somewhere around that or maybe a little bit lower, depending on how the hardness has been consumed. So first drop. So again, kind of a pale yellowish color, a little bit hard to tell there. Second drop. Sort of helps again to look at them from the top if you really just need to see that pure color change. So it looks still pretty yellow there. Third drop. Still yellow. Drop number 4. Still yellow. Five. So you can see, let me see if I can change the angle on that. So that looks pretty green to me. If you again, if you look at it from the side, it's a little bit hard to tell. Sometimes I put them against the, the white background of this. So that's what I mean. A little right there, it's kind of a lime yellowish green. If you look at it from the top, it's to me that's definitely on the green side. So that was 5 drops. We'll add one more just to see if that. So it looks a lot more green. So I'd say somewhere between 5 and 6 drops. So that's about somewhere between 90 to 120 parts per million of general hardness. So again, with koi ponds, the school of thought is that you want to keep your GH or your general hardness around 100 parts per million or higher if you're also buffering your water with baking soda. So again, I don't have a lot of proof or theory behind it, but what I've read is that it can start to affect your Benny or the red coloration on the fish if you're buffering with high pH, but not also raising your GH to compensate. So again, you can see this thing from a distance. It's definitely green there. So for me, somewhere between 5 to 6 drops is good enough on my GH. That's essentially where I want to be. If it were to be lower, somewhere in the 3 to 4 drops range, like my tap water is, I have this other container here, which I use to raise the GH. So this is calcium chloride, or your swimming pool pH, or sorry, not pH, but hardness increaser. So I get this on eBay. You can get about for $1 a pound. I buy it in bags or boxes of 25, 30 pounds. Pretty cheap, easy way to do it. So again, you can go to your swimming pool store and just your generic calcium chloride hardness increaser for swimming pools. I add this at the rate of 1 pound per 1,000 gallons. So again, 4 pounds for my pond. If I were to get a reading somewhere, less than 4 drops, I would add about 4 pounds of this stuff into the water, and that would hold me over for, the GH. It'll hold steady for anywhere from 3 to 4 weeks, I think. So, I don't add this one too frequently. As long as my water is not way too soft, then I typically don't worry about it. So. All right, so that was the last test I wanted to talk about, and hopefully that was a little bit helpful for you guys and kind of showing the testing routine that I go through with my pond, how I check my water parameters, and how I interpret the results and what I do with them. So based on all the levels today, for me, no action needed. Don't need to add any baking soda to buffer the water. Don't need to add any calcium chloride to raise the general hardness of the water. Ammonia, pH, nitrite, nitrate were all in line. So again, hopefully that helps. Any questions, comments, feel free to drop them below. Thanks, guys.